Okay, so as I said, we'll come back to that quiz in a little bit. Want to talk a little bit about vector addition and uses of vectors. We've been looking at adding vectors. What we want to look at now is something called an equilibrium. What equilibrium means is the sum of the vectors equals 0. Now we've kind of discussed equilibrants. It's something called an equilibrant. Is the vector required to bring a system back to 0? And actually the equilibrant is nothing more than the inverse of the sum. What do I mean by that? Well, let's say we just have a single vector. So if we have just a single vector, let's say this is our vector here. So it's 40 degrees, and that is 600 pounds at 40 degrees. The equilibrant would be what brings it back to 0. That would be the inverse. That would be 600 pounds at 220 degrees. That 180 degrees out of phase. If I had components, px of 50 pounds and py of 80 pounds, the equilibrant would be px of negative 50 pounds and py of negative 80 pounds. Just put them in the opposite direction. Those add up to 0 in both directions. So let's say I have two vectors. I have vector A, which is 200 pounds at 150 degrees, and vector B, which is 300 pounds at, let's go 60 degrees. So we're going to first add them together. So px and py here. Px is, of course, 200 times cosine of 150, which is going to be, what, 173.2, I believe, pounds. Negative, right? Py is going to be 200 times sine of 150 degrees, which is going to be 100 pounds. This should be negative here. 100 should be positive. Py would still be positive. Okay, so B, Px is going to be 300 times the cosine of 60, which is 150 pounds. And Py is 300 times the sine of 60 degrees, which is going to be what? Was it 259.8 or something like that? Perfect. So we have those components. I'm going to give you guys a second, add them up to find that vector sum. So we added those up. We got, what, negative 23.2 pounds horizontal and 359.8 pounds vertical, giving us 23.2 and 359.8, giving us a resultant here, a magnitude of What'd you get when you did that? So let's see. What's that? 360.55. That sounds about right. Pounds at this angle here was, of course, the inverse tangent of 359.8 over 23.2. Gave us what? 86.31 degrees. Of course, that's not our angle. That is the actual directional angle is this one here. So this is at 93.69 degrees. So that's our resultant. So from our resultant, to find our equilibrant, we have two possibilities. The easiest one is just add 180 degrees to this, right? So our equilibrant is going to be 360.55 pounds at 273.69 degrees. Now, fortunately, what we could have done, we can analyze both the horizontal and vertical directions separately. If I were to find the components of this vector here, it's going to have a px of negative 150 pounds, or sorry, not negative, but of positive 23.2 pounds, and a py of a negative 359.8. Those are the same components of our resultant, just reversed direction. Change the sign. Made if they're negative, they become positive. If they're positive, they become negative. Where is this important? Well, let's look at a simple example here where we have, this is a wall. We'll label it for Jordan. Hanging off our wall, we have a shelf. Our shelf is holding a weight of 400 pounds, right? And it's going to be supported by a cable. I want to know how much force is on that cable in blue there. Well, a basic rule here is that 400 pounds, if we assume it's at the center of that shelf, 200 pounds goes to each end. So there's 200 pounds here, 200 pounds here. So that means the wall has to lift up, has to balance that 200. The wall is lifting up with 200 pounds. Does that affect the cable? No, that part does not. The cable has to lift up with 200 pounds of force. But is that the exact force on the cable? No, because the force is not going, the cable's not going straight up. If that cable is straight up to the ceiling, yes, then it would be 200 pounds it would have to hold. Because it's angled back at the wall like that, it's going to be more. So we do need to know this angle here. Let's say that this angle here is 55 degrees. So what that means then is the vector, the force on that cable, let's just call it C for cable, has a vertical component, Cy, of 200 pounds. What is the horizontal component have to be? Well, I'm going to look at that triangle right there. That's a right angle because the angle between vertical and horizontal is always a right angle. This here is the 200 pounds. Do we know any of the angles in here? Yeah, we know this angle here has to be what? This was 55 down here, so that one is 35 because those add up to 90 degrees. This one up here is actually going to be 55 degrees. What does this amount here have to be? Well, that's going to be a tangent. Tangent of 55 degrees equals opposite of 200 pounds over, that's actually our CX, right? Over CX. Put this over 1, we cross multiply and divide. So we've got 200 divided by the tangent of 55. We got 140.04 pounds. So that is the horizontal component. So what does that mean? That means that cable, in order to lift 200 pounds, has to pull back towards the wall of 140 pounds, basically, which means the wall here has to push out with 140 pounds, 140.04. So the overall magnitude of the force on that cable right here is the square root of 200 squared plus 140 squared. Giving us 244.13. So basically that cable has to hold 245, 250 pounds. What has to be capable of. Make sense? Seeing a couple of blank looks. Okay, we're gonna leave it at that, and we will talk more about this on Monday. I'll let you guys have the rest of the time, the last 28 minutes here to work on your quiz.